Okay, promised you a few more extra examples for trigonometric solving, so here we go. In this case, we have sines and cosines on both sides. Problem is, if I just go subtract and sine x off both sides, I have cosine x minus sine x minus 4 equals negative 4. Add 4, I get cosine x minus sine x equals 0. I don't know what to do with that because those are not squared. There's not anything. So I don't love that. Let's do this. Let's add 4 to both sides. Okay, if I add 4 to both sides, I now have cosine x equals sine x because those cancel each other out. Now, at this point, we said be careful, don't divide both sides by things because you could eliminate a solution. But I'm going to do exactly that. I'm going to divide both sides by something. But you'll notice I'm not canceling anything out over here. Now, this will turn into 1, as it should. But over here, I'm not canceling it out. I'm saying cosine x over sine x equals, well, wait a minute, that's cotangent x. So cotangent x equals 1, so now my question is, where is adjacent 1 and opposite 1? Well, adjacent is 1 and opposite 1. There we go. That's going to be at 45 degrees. 45 degrees, also known as pi over 4. 45 degrees or pi over 4. That, by the way, is the only place that happens because if it were down here, it would be negative over negative. So we have that as a potential option. Okay, let's do another one. Let's take a look at secant squared tan squared x plus 3 secant squared x minus 2 tan squared x. Okay, let's see what we have here to work with. Oh, equals 3. All right, 1 second. All right, not sure where to go with this one entirely. Let's see if we can get rid of some stuff. Let's either change it into all tans or all secants. Well, let's change it into all tans. So our key phrase that we're going to use is we got tan squared x plus 1 equals secant squared x. So everywhere I see secant squared, I'm going to replace it with tan squared x plus 1. Don't know if this is going to be any quicker, but that's what I'm going to start with. And sometimes when we're solving these out, that's just what we're going to do. We're just going to do the best we can do. Sometimes it's going to make a mess. Sometimes it's going to really work out. You're not just going to be able to do it correctly every time. There's going to be times where you're like, wow, that was a dumpster fire, and I don't like that at all. In fact, you know what? That is already starting to look like a dumpster fire. I don't really think I like that. So I'm going to leave it there. I'm not going to erase it because I may need something out of it later. I think what I'm going to do is I'm going to take this, I'm going to start again. And I'm going to say secant squared x, tan squared x, and minus 2 tan squared x equals, and I'm going to subtract this 3 secant squared from both sides. So I'm going to say 3 minus 3 secant squared x. Now, the thing is, as I was going through this, so wait a minute, I got a 3 and a 3 here. That might work to my advantage, because if I take a 3 out, that means 1 minus secant squared x. Ah, well that works nicely. And now I have something that has a tan squared in each case. So I have tan squared x, and take out, and I get a secant squared x minus 2. All right, well that's not as awesome as I'd like. But I'll give it a whirl. I could say 1 minus secant squared. 1 minus secant squared. Well, that's secant squared minus 1. So I have a tan squared there. So if I were to move all this to one side, tan squared x, parentheses secant squared x minus 2. And I'm going to take a negative out front, so that'd be minus, but I'm going to put plus secant squared x minus 1 equals 0. By the way, what I did here was I subtracted 3, parentheses 1 minus secant squared x, but then I gave the negative away, and that's 3